Hi everyone, here we have another further PO3 question, and these are, pretty complicated questions. They take some time to do this, so bear with me, and it might take around 20 minutes, So let's start the question. So the given y equals arc cos and sec x. So that basically means cos inverse sec x. This is it's a normal trigonometric function with a hyperbolic function. So they're asking us to show that dy over dx equals sec x. So let's just differentiate this. So dy over dx equals, so the differentiation of cos inverse x, is, I'll just write it separately, cos inverse x is minus 1 over root 1 minus x squared. You have to remember that, all right? So in this case, it's going to be minus 1 over root 1 minus sec x squared, right? Into the differentiation of what we have inside. So what's the differentiation of sec x? So we can rewrite sec x as 1 over cos x. So you use the quotient rule. So cos x to 0 minus 1 into the differentiation of cos x, which is sin x, over cos x squared, giving you minus sin x over cos squared x. This giving you sin x over cos x into 1 over cos x, right? So you can rewrite this as minus tan hx into sec x, right? So you can see it. So I'm going to erase everything. Because if you guys have any doubts with that part, just drop them in the comment section. So that's going to be minus tan hx into sec x. So now, minus and minus, they will cancel out. So now you have tan hx into sec x over 1 minus sec squared x. So you should know cos squared x minus sin squared x equals 1. This is in hyperbolic functions. Okay, but in normal trigonometric functions, we have cos squared x plus sin squared x equals 1, right? But this is different. This is hyperbolic functions, so it's minus. So you divide every term by cos squared x, you get 1 minus tan squared x equals sec squared x. So you can see 1 minus sec squared x equals tan h squared x, right? So instead of writing this, you can write tan h squared x. So this gives you tan hx into sec hx over tan hx. They cancel off. This gives you sec x. As you can see, we got the first part. So then the second part is if figure 1 shows a sketch of part of the curve C with equation y equals fx, where fx equals cos inverse sec x plus cot hx. The point P is a minimum turning point of C. Show that the x-coordinate of P is ln q plus root q, where q equals half into 1 plus root k, and k is an integer. Toledo. Okay. See what you are doing is, let's write fx equals cos inverse sec x plus cot hx. Isn't it? So let's differentiate this because they say a minimum point. So we have to find the x value. So to find the minimum point, dy or dx should equal to 0. So let's find f dash. F dash is the same thing as dy over dx, so let dash exists. This part we found earlier, which is sec x. And now we have to differentiate cot hx, right? So what's the differentiation of cot hx? We can write that as, so cot hx is 1 over tan hx, which is cos hx over sin hx, right? Now we have to differentiate that. So we gotta differentiate cos hx over sin x. You use the quotient rule. Let me just write the quotient rule to you guys. V du over dx minus u d v over dx over v squared. This is the quotient rule, right? Numerator is v, sorry, denominator is always v, numerator is u. Okay? So it's sin hx into the differentiation of cos x is sin h, say sin x minus cos x into cos x over sin squared x, giving you sin squared x minus cos squared x over sin squared x. The numerator you can rewrite it as minus 1 into cos squared x minus sin squared x over sin squared x. So you can rewrite, not rewrite, cos squared x minus sin squared x is 1. Right? So it's minus 1 over sin squared x. Still now. Back to the equation in the hand. So dy over dx equals to sec x minus 1 over sin squared x. So 0 equals, so dy over dx equals to 0. Okay? So I can write cos sec x as 1 over cos x minus 1 over. And for sin squared x, I can rewrite that as, because we know cos squared x minus sin squared x equals to 1. So then sin squared x is cos squared x minus 1, right? Okay, so now we can take a substitution. We can take cos x equals y. Something like that. Makes it easier. So 1 over y minus y. 1 over y squared minus y. Minus 1. So now let's multiply everything with the denominators. So you get 0 over y squared minus 1 over y minus 1. Now I'm going to multiply everything with y. minus y. So you get y squared minus y minus 1 equals 0. So for this, we'll use y equals minus b plus or minus b squared minus 4ac over 2a. Right? So then, minus b is, so that's 1 plus or minus b squared 1 minus 4 into 1 to minus 1 over 2. Giving you 1 plus or minus root 5 over 2. So y equals 1 plus root 5 over 2. You can only take the positive value, because if you take a negative value, you get a, if you put negative root 5, you get 1 minus root 5 over 2, giving you a negative value. And you cannot take cos inverse of that value. So we had y equals cos inverse, right? So we can write cos x equals 1 plus root 2. Do you know what's wrong with me? Root 5. Okay, so you also have to know that cos inverse x gives you ln x plus x squared minus 1. So here you can write ln 1 plus root 5 over 2 plus root 1 plus root 5 over 2 squared minus 1. So let's look at our square root. So we have 1 plus root 5 over 2 squared and minus 1. So that gives you the same thing. So you can write 1 plus root 5 over 2 plus square root 1 plus root 5 over 2. Let's just see in what form they're asking us to give the answer. Okay, so can write this as ln. You can take half out, and you can write this as 1 plus root 5 plus root half outside 1 plus root 5. Right? Because they're asking us to give the solution in that form. Because you can see ln q plus root q, and q equals half. See, do you see? Q equals half 1 plus root q. See? And the answer should be in this format to q plus root q. So see, you can see the format in my answer, right? You can see q equals 5 and q equals half 1 plus root 5. So these are your answers. That's everything for this question. I hope you guys understood. If you guys like my teaching, leave a like and subscribe. And that's everything for this question. Thank you so much and have a great day.